This is Shane. I'll be helping with John Anton with the math and with the editing.
My name is Austin Allard, and I will be doing the applied practice of the sport and hitting the golf shot.
Hi, my name is Maxi Martinez, and I will be doing the video editing skill.
Hi, my name is John Antoine, and I'll be doing the computations and the mathematical explanations for what's going on in our project.
When playing golf, there's a lot of different factors that are influencing the ball's projected path. The first and most important of these is the angle at which the ball is hit. When you hit the ball, there is an angle that is created. This is usually created due to the club that you are using, and the different type of faces will influence which type of angle is created. A wedge is usually the highest angle, whereas a driver will probably be one of the lowest angles. Each of these are used for different purposes, and there are different factors that will influence the ball's path, but none as much as the angle. Some of these other factors include the location and the weather of the location. These are the materials that we used in this experiment. The wedge is one of the 3 clubs that we used in this experiment. The wedge has one of the highest angles out of all of the clubs, and in this experiment, we used a 56 wedge for the initial part of the experiment. The next club we used in this experiment was a 7-iron. It is usually used to make shots that are between that which would be attainable by a wedge club and a driver club. The last club we used in this experiment was the driver. The driver is usually used to attain longer distance shots in comparison to the wedge and the iron. We also used a cell phone in order to record different shots of Austin hitting golf balls. We had to have a full set of clubs in case we needed to change the angle by changing the club itself. This is a shot of Austin hitting the ball in slow motion. Now here is a sped up version so you can see how the fluid motion looks like. A chimpanzee can throw an object at 8.4 meters per second, and the distance that this object lands at is usually affected by the angle.
For this project, we're going to be using 3 different clubs, and with each of the different clubs, we are going to be determining the average time that it takes for the ball from the initial contact point all the way until it hits the ground, and then calculate the average angle that would be necessary for different values of distance that we ourselves will determine using the angular launch equations.
In order to get the different angles necessary for each of the different clubs, we used the equation delta x is equal to vi cos theta times time. This equation will give us the approximate angle that would be necessary in order to attain a certain delta x. For the wedge, Austin hits somewhere between 100 and 175 yards. So we decided to go with approximately 150 yards, which translates to 137 meters. Then for the delta x for the iron, we use 200 yards in the actual equation. That then translates to about 183 meters. For the driver measurement, we decided to go with the upper bound closer to 325 yards, which translates roughly to about 300 meters. For the wedge, we got approximately 60 degrees, with an exact angle of 61.92 degrees. Next would be the iron, which was roughly 36.28 degrees. This meant that the best iron type to use would be a 37 degree iron, which is more commonly referred to as an 8 iron. The final driver to be used was a similar type driver with modifications that would make the angle face 60 degrees more towards the ball, resulting in a total angle of the club face itself of about 17.85 degrees. The results of the experiment would conclude that our math was right. Understanding how the angle of a hit is incredibly important to not only the sport of golf, but to multiple other sports as well. The angle of a hit can substantially change the trajectory of the object that is being launched, and thus it is important to understand this relationship